Hey guys, so I know that a few of you guys were absent on Thursday before we left, so March 12th, and we did this note page 12 on that day. And so I know a lot of you are kind of a little bit confused on worksheet 12, what to do on that because you're not really sure what's going on with note page 12. So I wanted to briefly go over note page 12 with you. Basically, just the top talking about why we learn how to simplify radicals or simplify square roots is mainly because they're inverse operations of exponents, meaning that they can undo exponents, which is really, really cool. And how we simplify square roots is by using something called prime factorization. So prime factorization is basically just breaking down the number into only prime numbers. For people that don't know what prime numbers are numbers that can only be multiplied by 1 in itself. So like, for instance, 1 is a prime number because it's just 1 times 1. 2 is a prime number because it's just 1 times 2. 3 is a prime number because it's just 1 times 3. 4 would not be a prime number because I can do 1 times 4 and 2 times 2. So when we're looking at prime numbers, we're really looking at just the numbers that can be multiplied by 1 in itself. So some key prime numbers, if you're interested, we have 1, 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31. So you'll notice that pretty much none of them are even except for 2 because anything that's even can be divisible by 2. So again, these are kind of some, important prime numbers if you want to know. Another thing you should know as well when you're looking into simplifying radicals is your perfect squares. I would make sure that you memorize these. So like for instance, the square root of 1 is 1, the square root of 4 is 2, square root of 9 is 3, and so forth, okay? So basically what you're going to be doing is you're going to be starting by breaking these down into prime numbers. So for instance, you're going to ask yourself, what times what gives me 24? Now, again, you could do 3 different things here. You could do 2 times 12, you could do 3 times 8, or you could do 6 times 4. Either way, it doesn't matter. If you're bad at multiplication, just always go with 2 and see if that works. For instance, what I mean by see if that works is you only want to, you don't want to put a decimal here. So if you divide it by 2 and it gives you a decimal, you wouldn't want to use 2. And then you keep breaking things down. So for instance, 12 is not prime because we can say 2 times 6. And then 6 is not prime because we can say 2 times 3. And so 2 is only 1 times 2, and 3 is only 1 times 3. So the prime factorization of 24 would be 2 times 2 times 2 times 3. Okay, so this is basically kind of how we start. We just say basically what times what gives me that number. And again, if you're not very good at knowing this, always do 2. So 2 times 16, and then 2 times 8, and then 2 times 4, and then 2 times 2. So this is 5 2s. And then 42, same thing. So 2 times 21, 3 times 7. So this would be 2 times 3 times 7. Okay. Now, once you've gotten all of those prime factors, then what you have to do is you're going to circle pairs of the same number. So I'm going to look at all 4 of these numbers. And so I have pairs of 2s here. I have a pair of 2 here. I have a pair of 2 here. And I have no pairs here. When it's a pair, they go outside the radical. So this 2 comes outside my radical. When it's not paired, it goes inside my radical. So this 2 and this 3 are going to go inside my radical. And then I'm going to rewrite this with the 2 times 3. So this would be 2 radical 6, which would be essentially what the simplification of radical 24 is. So on this one, we'd have 2 2's on the outside, so 2 times 2, and then we'd have 1 2 on the inside of the radical because it's not paired up. So 2 times 2 is 4, so the simplification of radical 32 is 4 radical 2, okay? Now on this one's unique. It has no pairs. So what that basically means is that nothing can come outside the radical, so we just end up with radical 42. So our final answer is radical 42. Final answer here is 4 radical 2. Final answer here is 2 radical 6. Okay. Now, when we are talking about simplifying radicals, we're just basically not changing them too much, just making them down into prime numbers as much as we can. Another way to do this is just basically to use your calculator. So like this is approximate the value of each square root above. So when we say approximate, we're talking about like how much is this about? So for instance, radical 24 is right underneath radical 25, and the square root of 25 is 5. So this one probably is somewhere between like 4.9. So somewhere between 4 and 5, but since it's closer to 25, it's around 4.9. The square root of 32 is in between 25 and 36, so it's probably 5 point something. So for instance, if we approximated this, if we look at 32, 25 and 32 are 7 away from each other. 32 and 36 are 4 away from each other, so it's probably closer to 6, so maybe about 5.6. And then the square root of 42 is in between 36 and 49, so it's probably somewhere between 6 and 7. And 42 is 6 away from 36 and 7 away from 49, so it's probably 6.4, 6.5, or maybe 6.45 essentially. And so we're kind of estimating it. So another way that you can do this is kind of estimate what the values are using perfect squares, okay? For your guys' homework, worksheet 12, basically you're going to be doing exactly what I just did with H, I, and J. So you're just going to be basically breaking them down and simplifying them, and that's going to be pretty much how you're going to get your worksheet done. Another thing on worksheet 12 is also talking about irrational and rational numbers. So just to remind you about rational and irrational. So irrational numbers have no end. So for instance, like pi or the square root of 7. So if I put in the square root of 7 into my calculator, for instance, so if I put this in, so square root of 7, it gives me this long decimal that doesn't end, okay? So because it doesn't have an end, that's why it's irrational. Rational numbers have ends. So for instance, 2 or 3.1. Anything that has an end, square root of 16, which essentially is 4, okay? So when it has a specific end, then it would be considered rational, all right? And then you guys can skip number 9 because we didn't get to that on this note page. So you don't have to do that for the worksheet 12. So pretty much everything else on this note page is just talking about your next class, so like in integrated 2. So I wouldn't worry about the extension part, but if you can do this on your worksheet, then that would be ideal, okay? All right, so again, let me know if you have any questions on the Zoom session, and then we'll kind of go from